This video is about how to real-life applications of exponentials and logarithms, okay? I think you'll never use this, but it does have application in real life. So really, we just got a couple examples to look at. All right, first of all, financial. Let's say you deposit $500 into an account that pays 6.75% interest, compounding continuously. That's a good deal. How long will it take you to double your money? All right, so if you recall, there's a good old equation we talked about. If it compounds continuously, we use this one. The A is the balance of the account equals the principal, what you put in initially, times E raised to the rate multiplied by the time. All right, so when you, first thing you're going to have to do is identify what the different values are going to be. All right, so A, what is the amount of money I want it to be? Well, I'm looking for how long it's going to take to double my money. So how long is my T? That's the unknown here, okay? The amount I'm looking for is double whatever 500 is, which we know is 1,000. The rate is 6.75%, but I have to convert that to a decimal, so 0.0675. And then the principal. How much did I initially put in? $500. All right, so these are my values. I need to just write them into my equation, and then we're going to solve it. So 1,000 equals 500 times E raised to the 0.0675 times T. All right, so now we have a good old exponential equation we need to solve. And just like before, we need to isolate that exponent. So I need to get rid of the 500. So I'm going to divide by 500. And I'm going to get a 2 equals E raised to the 0.0675 T. Now, if you recall, what did we do to get the T out of the exponent? If you remember, we had to take the natural log of both sides of the equation. So we did the natural log of 2 equals the natural log of E raised to the 0.0675 T. So natural log of 2 stays put. I'm just going to scooch it over here. So I have the natural log of 2 equals, natural log of E is just 1, so the power drops down. And I can solve this now for T. So I simply need to divide by 0.0675. And that'll tell me what T is. Okay? Now, once I put that in my calculator, the natural log of 2 divided by this decimal, I get this number, 10.269, blah, 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 blah. All right? But the question is, how long is it going to take? So this is, T is in years, my number of years. So when we're doing application problems, you want to answer in a complete sentence. So what I would say is, it will take approximately 10 years to double the money, or double the investment, however you want to say it. But yes, you need to write it in a complete sentence. Okay? It will take approximately 10 years to double the investment. You will see this more and more. So hopefully that makes sense. Make sure you have, if you have questions, ask them. Okay? Okay, for example 2. The number of endangered species in the U.S. from 1990 to 2002 is modeled by this equation right here. Y equals -119 plus 164 natural log of T, where T represents a year. So if I solve it and T is 10, that really is talking about 1990. So 11 would be 1991, 12, 92, so on and so forth, up to 22, meaning 22 would be 2002. So this is how you interpret your answer. That doesn't affect how you solve it. It just affects how you interpret the answer. So during what year was the number of species 357? So I'm solving for T. All right. So I'm going to plug in a 357 for Y. All right. So I need to start by isolating this natural log of T. So first thing I'm going to do is add a 119 to both sides. I'm going to get 476 equals 164 natural logs of T. Now I divide by 164. So now I have this 476 over 164 equals the natural log of T. All right, I'm going to scoot over here just for some space. Okay, when I put that in the calculator, I get 2.0 902, just to make it easier. Now, I've got to get t out of the logarithm, and the rule is to make it an exponent with the same base as a logarithm. Well, the base of this logarithm, since its natural log, is e. So I have to make everything base e. So I'm going to do it to both sides. 2.902 equals e to the natural log of t. All right, so now we simplify it. E to the natural log of anything cancels, and t comes down. And I have e to the 2.902. And so when I calculate that out, I get that it's 18.219. Okay, so that's t, but remember I need to interpret that. So it's relatively 18. So I need to think, okay, what year would that be? If 10 was 1990, that means 18 is 1998. So my answer would be the year. Okay, for the whisk, you try one of these endangered species problems. Okay, again, I'm asking what year was the number of species approximately 380. Okay, here's the equation. It was y equals negative 119 plus 164 natural logs of t. That was the equation, and remember, if t was 10, that was 1990. If t was 22, that was 2002. All right, so make sure your answer is as a year. That's what I'm looking for in the whisk, is what was the year. All right, good luck and see you in class.